Math 1314, Tyler Junior College, section 4.1, exponential functions. Graphing exponential functions, part 3. I may split this into a part 4. I've got 2 examples planned. I'll check the time after the first example. In fact, I'm going to write check time up here so I don't forget. And if this video seems like it's going too long, then I'll stop it and start part 4 to do the second example. On the left here, you see a summary of the types of graphs we've seen so far. F of x equals b to the x, where the base is greater than 1, was exponential growth, with our reciprocal point, -1, 1 over b, our y-intercept of 0, 1, and our base point of 1, b, along with our horizontal asymptote of y equals 0, and our exponential decay, f of x equals b to the x, where the base is between 0 and 1. We still have our reciprocal base point, our y-intercept, and our base point, and the same horizontal asymptote at y equals 0. The only difference is the graph is decreasing instead of increasing. And we're going to graph 2 functions using transformations that we learned back in section 2.5. For the first example, we'll graph f of x equals -3 to the x plus 1 power, and then plus 2 at the end. What I've got on the board so far are the base point, y-intercept, and reciprocal base point for f of x, or excuse me, for y equals 3 to the x. I don't want to call it f of x because that's what this is, so we'll just say y equals 3 to the x. And I haven't drawn the graph through them, but it's going to look like this and go through those 3 points. I also have the horizontal asymptote already sketched at y equals 0. So you can use your imagination and see the exponential growth graph that would go through these 3 points. But what I want to try to do to sketch this is to identify the transformations that occur based on the changes to the function, and then use those transformations to keep track of our base point, y-intercept, and reciprocal base point, as well as the horizontal asymptote, by following their journey through each transformation. When we discussed transformations of functions, there was a particular order in which you address them. Namely, you address the shape of the function, and then any reflections, and then any translations. In this case, we have no changes to the shape of the function because there's no multiplication in front of the x, like there will be in that one, and there's no multiplication in front of the function. You could argue the -1 is, but that will invoke a reflection. Speaking of which, this -1, this negative in front, will invoke a reflection across the y-axis, across the x-axis. So that's going to be our first move. Reflect across x-axis. After that, we can handle the translations, moving the graph. The +1 on the x moves it in the x direction, but the opposite of what you would expect. You would expect a +1 to move to the right, but it actually moves to the left 1. So that will be our next transformation. And then the +2 at the end does what you expect to the y's in the y direction. It would move the graph up 2. So what we're going to do is we're going to figure out what happens to each of these points along with the horizontal asymptote under each of these transformations and replot them and resketch the graph. Let's start with the reflection across the x-axis. When you reflect across a point across the x-axis, you are changing the sign of the y, because if it used to go up, now it goes down and vice versa. So all we have to do to reflect these across the x-axis is to change the sign of the y. So 1, -3, 0, -1, -1, -1/3. And since this is a y value, we would change its sign, but changing the sign on 0 keeps it 0. And now we're going to move everything to the left 1. When you move a point to the left 1, you subtract 1 from its x coordinate. So on each one of these, I'm going to subtract 1 from what x equals. Subtract 1 from here, we get 0, -3. Subtract 1 from here, we get -1, -1. Subtract 1 from here, we get -2, -1/3. And if we're going to subtract 1 from x, nothing happens here because there is no x to subtract 1 from. So this is still y equals 0. And then finally, to move a point up 2, you would add 2 to its y coordinate. So I'm going to add 2 to each of these points' y coordinates. So add 2 to -3 to get 0, -1. Add 2 to -1 to get -1, 1. And add 2 to -1/3, and this is where you have to be a little careful with the arithmetic, but 2 plus -1/3 is 5/3. And if we add 2 to this y value, we get y equals 2. So now that we know where all these points go, let's just retrace them. And I would start with the asymptote, because we know that this graph's going to approach the asymptote. The asymptote is going to be at y equals 2, so we'll start by drawing a horizontal asymptote through y equals 2. And now let's just replot all the points. The base point ended up at 0, -1. 0, -1 is here. By the way, I'm expecting this to come up from the bottom upwards because, I'm expecting it to be from the asymptote downwards because it looked like this and we reflected it. So I'm expecting this is going to go right through where I wrote that ordered pair. That's what I was trying to get to, why I put the ordered pair where I did. The y-intercept moved to the point -1, 1. So -1, 1 is about here. So there's -1, 1 right there. And then our reciprocal base point moved to -2, 5/3. So back 2 and up 5/3. Well, 5/3 is just a little less than 2, because 2 is 6/3, and that's just a little less than that. So when we go back 2, we'll be up. These points are on the way. Thank you. I appreciate what you guys did for me. Get out. All right. So -2, 5/3 is back 2 and almost up to the horizontal asymptote, which makes sense because we're supposed to approach the horizontal asymptote on the left side of this graph. And so if we reconnect, you get something that looks like this. Now, can you move this graph without literally keeping track of these 3 points? You can, but I'm just shooting for a little bit of accuracy, and those are some good points to keep track of. -2, 5/3 is where the reciprocal base point wound up. But if I were to redraw the original graph, which I just literally erased the points that it went through, but I can still kind of see them, the original graph kind of looked like this. So it does look like you got reflected, moved to left a little bit, and then up some, which is how it's supposed to be. Let me check the time. I'll probably stop the video and do a part 4 anyway, just to make up for the ridiculously long videos before. Yeah, we're already at the 8-minute mark, and I imagine the next one will take about another 8 minutes. So we'll stop this and have a part 4 and look at the other example.